So this is now take 3, okay? So for this video, I want to discuss simple interest, okay? First of all, we need to do some definitions to figure out the different components of a simple interest calculation. Then we'll look at several examples, and then hopefully that'll give us a good base so that we can then move into compound interest, annuities, mortgages, and other more complicated calculations, okay? For now, let's go to the whiteboard. Okay, and as always, it takes me a second to get settled, so there might be a little bit of noise. Okay, so we have simple interest. And it is simple for a reason. The calculation is nice and easy, okay? But there are some main components. The first one is interest. I'm going to change the definition slightly from what's on your notes packet. This is money earned on an investment or money owed on a loan. So let's say you find yourself in a situation where you have some extra money, you win a lottery, you saved really well, you get an inheritance, whatever the case may be, and you don't want to have that money just sitting around doing nothing. So you put it in a certain type of savings account. So you want to shop around, you want to find a savings account that has a good interest rate, okay? And then as you put that money in the bank every year, you're going to accumulate extra money. So it's kind of like the bank pays you to have your money sitting there, okay? And then on the flip side, let's say you find yourself in need of some cash, you need to buy a car, you need to pay for school, you need home repairs, whatever the case may be. You go to a bank and you're like, hey, I need to borrow money. They're like, okay, but we're going to charge you to use our money, okay? So they're going to charge you a specific interest rate. So at the end of the loan, you'll pay back everything you borrowed plus interest, okay? Next, we have principal. This is the initial amount that we deposit or borrow. So the amount deposited or borrowed. So let's say you have an inheritance of $25,000. You want to park it in a savings account to earn interest. $25,000 would be the principal. Let's say you have to borrow $12,000 to buy a car. $12,000 would be the principal. Now you have an interest rate or just a rate. And there's a few things you need to know about this. It's given as a percent. Assume it's an annual rate unless otherwise stated. That's otherwise, I swear. Unless otherwise stated. And it's going to vary bank to bank. It can even vary loan to loan or investment to investment. Varies bank to bank. You could go to a bank and need to borrow money to buy a car, and you could have several things that impact your interest rate. So the time of the loan, for example, your credit rating, different things can impact the interest rate. Now, time is not on your sheet, but I'm going to go ahead and put time. So if interest rate is annual, and again, we always assume the interest rate is annual, then time is in years. Okay, so again, almost everything we're going to do, the interest rate is going to be an annual interest rate. So that means time would be years. Now, here's the formula. For simple interest, we have I equals PRT. And then we have two other formulas that could come up. So this is just interest. And then we have A equals P times 1 plus RT. This finds future value. And then we have P equals A over 1 plus RT. This finds present value. And I'll explain these as we use them. So the first one we're going to use is right here. We're going to find just interest for the next few examples. Okay, so for the first example, you deposit $3,000 in a savings account which has a rate of 5%. We're going to find the interest at the end of the first year. Okay, well, the principal, or what we're initially going to invest or borrow, in this case, we're investing, is $3,000. The interest rate is 5%. They don't specify anything, so this is an annual interest rate. Again, always assume it's an annual interest rate. If they wanted a monthly interest rate or something, they would absolutely specify that it is a monthly interest rate. Okay, and then time is going to be just 1 year. Okay, so we have I is what we're looking for, interest is what we're looking for, and it is P times R times T. So we take the amount we're borrowing, multiply it by the interest rate. Now, here's the thing. In a mathematics class, when we're dealing with interest rates, they always have to be given to us in decimal form when we put them in the formula. So you might get an interest rate that's given to you as a percent, but then you have to put it or give it to the formula as a decimal. So you want to convert your interest rates to decimals, and then we want to multiply by time, which is just 1 year. And as long as you show me this, I'm perfectly okay with you using your calculator for the multiplication. So we would do 3,000 times 0.05 times 1, and we get 150. Okay, so at the end of a year, this savings account is going to earn an additional $150. So then question, how much would be in the account? Well, any interest just gets added right back to the account. So you would have the 3,000 that you started with plus the 150 that you earned. So your account would then have a balance of $3,150. Okay. So next example, a student took out a simple interest loan for $2,400 for 2 years at a rate of 7%. What is the interest on the loan? Okay, so again, we have I equals PRT. Principal, that's what we initially borrow, is $2,400. We have an interest rate of 7%, and we're borrowing this for 2 years. Okay, so we want to know how much extra money, how much interest we're going to owe at the end of 2 years. So we take 2,400 times 0.07. Again, you have an interest rate as a percent, but you have to put it into the formula or give it to the formula as a decimal. And then we want to multiply by 2 years. So again, once you write this out, you can use your calculator for the calculation, the multiplication in this case. So we get 2,400 times 0.07 times 2. And I get that we're going to have $336 owed in interest. So then how much do you end up paying back? This is not on your worksheet. I'm just adding this. So how much do you end up paying back after 2 years? Well, we originally borrowed 2,400. We've added an additional $336 in interest. So at the end of 2 years, what you're going to end up paying back the bank is $2,736 owed after 2 years. Okay. So those are 2 examples of just calculating plain old simple interest. For the next 2 examples, I want to look at, well, the next 2 examples, we're going to look at future value of a loan. And it doesn't have to just be a loan, it could be an investment too. So future value. So this tells us how much is in an account after a certain time period. Okay, so we have the formula A equals P times 1 plus RT, where A, whoa, that looks messy. where A is the future value. So that's how much is actually in the account after 1 year or 2 years or 10 years or whatever the case may be. P is either principal, or sometimes you'll see it called present value. So P would just be how much money you have today versus A, which is how much money you have at a certain point down the road. R, again, is your interest rate. It will be given to you as a percent. You then put it into the formula as a decimal. And then T is time. Again, it's always going to be in years unless the interest rate is not annual. Okay, so let's look at an example. Okay, we have a loan of $2,040 has been made. At 7.5% for 4 months. Find the loan's future value. Now, this could be confusing because you have 4 months instead of like a year or 2 years or whatever. So time is months, 4 months. Principal or present value is 2,040. Interest rate is 7%. Now, I do want to be clear here. They do not specify that this is a monthly interest rate. So again, interest rates are always annual unless they very clearly tell you the interest rate has a special type of term to it. This is an annual interest rate. We're just going to be paying back this loan in 4 months. This is a very short loan, but it's still an annual interest rate. Okay, so I do want to make sure that you understand that time is 4/12 of a year. Since this is an annual interest rate, time still has to be in years. Okay, so just be really careful here. So we get A equals P, which is 2,040, times 1 plus R, which is 0.075, times T, which is 4/12 of a year. Okay, you can type this directly into your calculator when you get to the 4/12. So you can just do parentheses 4 divided by 12 parentheses. So I do want you to type this exactly as you see this. So if you were on the calculator, you would type it like this: 2040 parentheses 1 plus 0.075 parentheses 4 divided by 12 parentheses. That's exactly how you would type it into your calculator, okay? So we get 2040 times 1 plus 0.075 times 4/12, and I get 2,091. So the future value of this account is $2,091. That means after 4 months, you would owe $2,091. So how much is interest? Well, after 4 months, we owe $2,091, but we initially only borrowed $2,040. So that means we accumulated $51 in interest over 4 months' time. Okay. So let's look at another example. So I always get a little iffy when I do something that could be semi-controversial. No judgment if you're a smoker. Okay. This is just a problem from your textbook. Okay. So it says, in addition to jeopardizing your health, cigarette smoking is a costly addiction. Consider, for example, a person with a pack-a-day habit who spends $5 per day, 7 days a week on cigarettes. So how much is spent in 1 year if a pack a day is $5 per day, 7 days a week for 52 weeks? That is one thing you need to know that maybe some of us don't. There are 52 weeks in a year. So we want to basically figure out how much is spent in 1 year if you have a pack a day habit and a pack of cigarettes is $5 a day. Well, you'd be spending $5 a day for 7 days in a week for 52 weeks in a year. So again, as long as you show me your setup, you can use your calculator to do the multiplication. And I get that this is $1,820 per year spent on smoking. Okay, so that's kind of like part A of this problem. Shoot, I just made that worse. So that's like part A. Part B then says, if this person invested the yearly spending on cigarettes in a savings account with a rate of 4%, how much would be saved after 1 year? So how much would be saved in 1 year if the cigarette money was invested in an account paying 4%? Again, if the percentage is just given to you flat out, assume it's annual. So we want to know the future value of 1820 at 4% for 1 year. Okay. So we get, whoops, I wanted to go to black ink. 1,820 times 1 plus 0.04 for just 1 year. And you can type it exactly as you see it right here. So again, as long as you show me your setup, you can go straight to the calculator. And I typed mine in wrong. Good for me, huh? And I get that you would save $1,892.80 after 1 year. So if instead of smoking for a year, you put that money aside and then you invested it, you could have $1,892.80 at the end of a year. Okay. So again, this is just simple interest, and we're learning how to plug. Basically, all we're doing is plugging values into a formula. So here's another example. You borrow $5,000 from a friend and agree to pay back $6,800 in 2 years. What simple interest rate will you pay? Well, first of all, I can say get a new friend because they're taking you to the cleaners. But that aside, we have a couple of things here. We have present value. This is how much we're borrowing today. We have future value. This is how much we're going to end up paying back. We have a 2-year time frame. What we're missing is R. We don't know what R is, but we have future value, we have present value, and we have time. So we're going to use A equals P times 1 plus RT. Okay. Well, the future value, what we're going to end up paying back at the end of 2 years, is $6,800. The present value, how much we're actually borrowing, is $5,000. We don't have a clue what R is, but we know that T is 2 years. So 2 times R, or T times R, is 2R. Now, what I want to do is distribute the 5,000 through my set of parentheses. So this is just solving an equation. So 5,000 times 1 is 5,000. And then 5,000 times 2R is 10,000 R. Now, I want to isolate the term that contains the R. So my issue is 5,000. I want to subtract that. Okay. So 6,800 minus 5,000 is 1,800. 5,000 minus 5,000 is 0. 0 plus 10,000 R is 10,000 R. So you can see here, your friend's making you pay back interest of $1,800. Your friend is a dirtbag. Okay. Now we want to get R alone. So the issue is this multiplication by 10,000. So we're going to divide. 10,000 divided by 10,000 is 1. 1 times R is R. And then 1,800 divided by 10,000 is 0.18. Now, remember, when we're plugging in a value for R, we plug it in decimal form, but it represents a percentage. So your friend is charging you 18% interest rate. So that's a really, really steep interest rate. Get a new friend. Okay. But there's an example of using one of the formulas, but having to manipulate it or solve for some other value. Let's do one more example. So for this one, it says, how much should you put in an investment paying a simple interest rate of 8% if you need $4,000 in 6 months. Okay, so we're given a simple interest rate of 8%, and it's just given %. What we're missing is what is P. Now, we have the formula A equals P times 1 plus RT. We can use this formula and then solve for P, or I know the issue with P is that it's being multiplied by 1 plus RT. So if I take both sides of this formula and divide it by 1 plus RT, that would give me P by itself. The 1 plus RT's cancel on the right, and we get that P equals A over 1 plus RT. You can use this formula right here, P equals A plus 1 over RT, or you can use the original, A equals P times 1 plus RT. Either way, it doesn't matter. I'm going to use the formula that's in a box. Okay, so we don't know what P is, so P equals 4,000 divided by 1 plus 0.08 times 6 over 12, or 1/2. Okay, so in your calculator, if you wanted to type this in, you would type in 4,000 divided by parentheses 1 plus 0.08, and then parentheses 6 divided by 12, or you could just do 0.5. 0.5 is easier in this case, but I'll show you the long drawn out version. So you would do 4,000 divided by parentheses 1 plus 0.08 parentheses 6 divided by 12 parentheses parentheses. And if you do that, you would get this is what you get on the calculator: 3846.153,846. Okay, so here's the deal. If you're looking for P, you always want to round up to the next cent or the next dollar. So in this case, it doesn't specify, so we're going to round to the nearest cent. But in this case, we always round up. When finding P. The reason is if we round down, we won't quite meet our goal. So I'm going to round up. So even though mathematically this would round to 15 cents, we're going to round it to 16 cents. That's what we would need to invest today. If we only do the 15 cents, we may not quite meet our goal. So that is a kind of a big deal there. So anytime you're looking for P, whether it's this section or future sections, anytime you're looking for present value, you always have to round up to the next cent or to the next dollar, depending on the situation. Okay, so there we have it. There we have it. So that's the basics on simple interest. It's called simple interest for a reason. There's not a lot going on. You're calculating interest for the year, basically. Okay. Again, assume your interest rate is always an annual interest rate unless very specifically otherwise stated. And I can think of like maybe 1 or 2 examples I've seen where the interest rate is not an annual interest rate, and it'll be very, very clearly worded if it's not. Now, time can be anything. Time could be 1 day, 1 week, 1 month, half a year. It could be anything, but just know that time needs to be written in terms of years because your interest rate is going to be an annual interest rate. Okay. Also, don't forget to round up for P. No matter what we do in this chapter, whether it's mortgages, car loans, annuities, compound interest, we always round up for P. Okay, so remember that. That's a big deal because if you don't round up, you won't quite meet your goal. All righty, so that's simple interest. Good luck. Let me know if you have any questions.